All right. First speaker for tonight, we brought Rainer Stropek again. He was already a speaker at a meetup in, I think, March this year. And he always supports us. He makes this room available to us. And he has a very interesting topic about model context protocol. Please give a big round of applause to a speaker from tonight.
Thank you very much. Yeah, thank you for having me. Thank you for giving me the opportunity to talk again at this amazing meetup here at the .NET Stammtisch. So my name is Rainer Stropek. I'm co-founder and CEO of Software Architects. We are a boutique consulting and software as a service building company in Leonding near Linz. And yeah, my topic today is model context protocol. By the way, I'm not sick. I'm just, now that we have the flu and everything going on, my calendar is full, so I try to stay as healthy as possible. So that's just me. Don't worry if we talk, it's no problem. Okay, let me ask you a few questions so I get to know you a little bit, because we can do this talk in many different aspects, in many different ways. First, let me ask you, who is using on a more or less regular basis AI for software development? Good, I expected that. Who is using GitHub Copilot? Okay, I expected that too. Who interacted with any large language model on an API basis? And I'm not talking about some abstract high-level framework for agents. I'm talking about the web APIs of OpenAI, Gemini, Claude, whatever, on an API basis. Who did that already? Okay, less hands, but still a few. Okay, who would say he or she is not fully aware what I mean when I talk about function tools in the context of large language models? Not fully aware, not fully aware. Okay, I guess a little bit more than half. So I now know approximately how we will go about that. We will start by introducing the concept of function calling. I will make that very short because you need to understand this. Otherwise, the entire rest of the talk doesn't make sense. So for those of you who know what function calling already is, hey, correct me, bring in your own opinions, just raise your hand and tell me what I say wrong or what your experiences are. And for the others, this will be a quick intro of what function calling really is. Let me do this intro here with the dashboard of OpenAI. It's a very nice dashboard for trying those developer-oriented topics. You all know what a developer message is. This is a system prompt, and typically in the developer message you define the persona. Come on, I don't want to have this. Okay. You define the persona, you are a helpful assistant for whatever. You define restrictions. You tell the system you are only allowed to answer these and that questions and you're not allowed to use whatever. And you typically define grounding data. So grounding data means data that is not available on the public internet, for instance, sharing your code so that the AI can reason on top of it and give you some answers. This is what a system prompt is all about. So let's write a very short system prompt. Let me zoom in a little bit. You are a helpful assistant supporting human coders in coding related tasks. Very simple system prompt. Let's keep it simple. Now I can ask the system, write a readme.md file for my project. And if I run this task, obviously it doesn't work very well because all the assistant can do, it can ask me, okay, I will write a readme file, but what is your project all about? Do you use C#, do you use Rust, do you use TypeScript, do you use JavaScript, whatever. It's not really useful. What we could do is we could provide in the developer message certain information. Here is a list of files in my project. I could say now I have my proj.csproj and program.cs, something like this. So if I would now ask the system, write a README file, it could at least understand that this is C#. Okay, fair? But this is not what we want. Instead, what we do and what modern LLMs are trained to do is we can add so-called function tools. Let me show you what a function tool is. Let's quickly generate a JSON schema for a function tool. This function tool, let me zoom in for you, is called readFile, reads the content of a given file. File path is a parameter, and this is a required parameter. That's JSON schema, what you see here. Now I can add this readme thingy here, and let's add another function. Let's call this one list files. Looks good, but I don't want to have any parameters. My list files is very, very simple. List files in the project, for instance. And last but not least, let's add, finally, a third function. This will be write content to a given file. And that will give me a file path, the content, both are mandatory parameters, and that's it. Now, what are these tools? These tools are abstract capabilities that we give to the model. We tell the model, hey model, I will now give you a task. And if you think it might be useful for solving this task to retrieve a list of files, then ask me. I can do that for you. So the model doesn't get a function pointer or a web API. It simply gets an abstract description of capabilities. And when it wants to call this capability, it simply generates a very special formatted text, a JSON island. In this JSON island, the model says, please call list files. And then I, as the host of the LLM, in our case, Visual Studio Code, for instance, I am responsible for checking that, doing the ls command behind the scenes, and returning everything, giving everything back to the model in return. So now it's way more interesting. Let's add the system prompt a little bit. Let's say it is your responsibility to use the provided tools to gather the necessary context. Before you call a tool, describe why you are doing that. Okay, let's do that. And now let's ask our model again. Please generate a readme.md file for my project. Do you do the same? I'm always very polite to LLMs. I don't know why, but I do it. Whatever. They're overtaking the world at some purpose and some time, and they will remember that, I'm pretty sure. And as you can see, the system says, I'll first expect the project files to understand its structure and purpose and so on, list files. This is the magic of modern LLMs. If you've never seen that, take a deep dive into function calling. It's so interesting what you can do with this stuff. And these models are amazing. You can give them dozens, if not hundreds of tools, and they can pick and choose the correct tools and even make sequences of these tool calls, make parallel tool calls. They can make tool calls in loops. Really amazing stuff. In this case, the LLM now thinks, okay, let's get a list of the files. The return type is not really, doesn't really matter. In most cases, we typically return JSON. So we could say myproj.csproj and program.cs. Okay, let's run this one. Next, it will take a look probably at these two files. You see? It asks me for how does these two files look like. Now let me quickly get a sample csproj file. Doesn't really matter. This is sample csproj file, and my program file simply contains console write line. Hello. That's it. This would normally be done by Visual Studio Code. And now I get a meaningful README file. See? Very nice. Now I have a meaningful README file. Now I can go one step further, write this README file to disk. I can do that, and hopefully it will call the writeFileContent method. Will only take a second. It's a rather long function call because the entire content of the README file is part of the parameter, and as you can see, it works like a charm. It now called the function call. Okay? So, for those of you for whom this is new, Let me show you something. If you are in Visual Studio Code, you have this nice little thingy here, this one, Configure Tools. You see it down here? And if you click on that, you see all these built-in tools. Let me zoom in a little bit, see? These are the function tools that Visual Studio Code has built in. And if I scroll down a little bit, you will, for instance, see here, see, read file, list directory, and things like that. I can move up a little bit, and if we say edit, you will see things like edit files, create directory, all these things. These are built-in capabilities that are built in Visual Studio Code. And guess what MCP is? MCP is a standard how we can equip an AI tool like Visual Studio Code with our own tools. So if we want to extend the list of function calls, list of function tools that our AI tool is giving to the large language models, we do that through MCP. If we go back, let's say 1.5 years, and you would like to do the same, you would have to use a Visual Studio Code specific SDK in order to write a Visual Studio Code GitHub Copilot extension. And guess what your problem is? You have to do the same for Cursor. You have to do the same for ChatGPT. You have to do the same for Claude. You have to do the same for Microsoft Copilot and for all the other AI tools. But we don't want to do that. As developers, we love abstractions. And this is what we do. We take the model context protocol, write the model context protocol server, and all these tools like Visual Studio Code, they are MCP clients. If you have an MCP client, it can talk to an MCP server. So we will now build, for the rest of the talk, extensions to the toolset of AI tools, and they work based on a standard so that we can use them across the board in all AI tools. Fair? Make sense? Yeah, there is way more about MCP. It's not just tool calling, but for now, that is fine. Many people criticize this protocol because of its shortcomings. No question about that. MCP has huge disadvantages, but still it is the best we have currently. Yeah, I think JavaScript and HTML are also not the best thing in the world, but it's the best we have, and we make the most out of it. And that's exactly true here. Good. Do we have any questions before I move on? We good? Fine. Nice. This is the modal context protocol. Let's go to light theme, because then you can read it a little bit better on the video beamer. This image essentially shows you what the MCP protocol is all about. You see on the left-hand side, you have different AI tools. And this is a very important takeaway. MCP is not a standard for large language models. In fact, the MC protocol, the MCP has, the large language model has no idea about MCP. No, not at all. MCP is a protocol between an AI tool, the front-end tool, and your application. That is what MCP is. So MCP is called by GitHub Copilot and Visual Studio Code, not by OpenAI GPT, not by Claude, not by Gemini. It's called by the tool, okay? So we extend the tool, not the large language model. It's a little bit strange if you are new to this world, because if you take a look at the dashboard here, and if I go again here, you will see that here, see, OpenAI GPT allows us to add an MCP server that looks and smells like the LLM talking to your MCP server. That's not the case. It's the API facade of OpenAI that talks to the MCP server. In this case, the API layer in front of the large language model is talking to our MCP server, not the large language model itself. The large language model only gets the description of the tools, and the large language model doesn't care if this tool comes from an MCP server or is built in a tool. Okay? Are we good? Keep that in mind. That's very important and a little bit confusing when you start with this whole stuff here. Okay. On the right-hand side, we have different different things we would like to make available to the LLM. It might be a local capability. It might be, I don't know, your file system. It might be a SQLite database that you have on your computer. It might be a Postgres database that is on your local area network. But it also might be a software as a service solution which runs in the cloud. And when it comes to software as a service solution, MCP is not so much a protocol of making it available because of network limitations, but more a trust delegation framework. So you give the MCP server the allowance, the permission to act on your behalf, and the LLM can talk through Visual Studio Code with the MCP server, so the LLM can work indirectly on your behalf with the software as a service system that you want to incorporate in your solution. For instance, you can say GitHub. GitHub runs in the cloud. So, for instance, Gemini could directly talk to GitHub, but it doesn't work because Gemini has no user credentials. So Gemini goes through the MCP server, through your credentials, your GitHub credentials, to GitHub, and therefore the LLM can indirectly use your software as a service solutions with your credentials. We can, if we want, do two different things here. On the one hand side, we can use a protocol which is called stdio, standard in and standard out. And the second thing is called streamable. You will see both in the rest of my talk. We can take the MCP protocol and create a simple, trivial console app. The tool, indirectly the LLM, will interact with our MCP server through standard in. It will essentially give us calls through standard in, and we give back our answers through standard out. Standard I/O, stdio, is the simplest possible MCP server that you can build. You can run it locally on your computer. You can run it in a Docker container. You can get it through NPM. You can get it through Docker. You can get it through NuGet. You can get it through whatever. There is no limitation of programming language. Do you want to write something like this in PowerShell? Feel free to do so. All you need to do is you need to be able to read things from standard in and write things to standard out. Everybody can do that, right? That's a great way of interacting with locally installed thingies. IoT devices, local disk, databases in your local area network, everything fine. The second option, streamable, is essentially MCP running in a web server. And in that case, the MCP messages are sent via HTTP post, and the answers are simply HTTP responses. That is not perfectly correct, what I say here, because the answer is not just HTTP response, the answer is server-sent events. So the answers are streamed back to the client, and you will see that in a few more minutes. This is why it's called streamable. When are you going to use streamable? Well, mainly if you are a standard software provider. IMAD, is that correct? IMAD, the company that we just had, did I remember it correctly? IMAD, yeah? The sponsor of today, IMAD, right? IMAD? Or IMAD, yeah. IMAD could, for instance, say, we provide an MCP server for our doctors, and we run it on, I don't know, api.imad.com/MCP. Why do they want to run it in streamable mode? Because doctors are typically not capable of installing software. And if they are capable, I have relatives who are doctors, they shouldn't be allowed to install software on their computers. They shouldn't. So IMAD could run this MCP server for them in the public cloud. And then they can take, for instance, Claude Desktop or ChatGPT, and simply all they need to know is the URL. They need to type in the URL of the MCP server, press enter, they have to authenticate themselves, and they are good. And suddenly, ChatGPT or Claude can talk to IMAD on their behalf. Maybe you don't want that because of security reasons, but that's a different topic. I'm not the one to decide that, that's up to you. But this is what you typically do with streamable. So with streamable, authentication becomes super, super important. And I will not talk about authentication today. A friend of mine, maybe you know Raphael Schwarz from Codeworks, he is specialized on OAuth and OpenID Connect and all this stuff. And he agreed somewhere next year to also be a speaker here, and he will tell you a lot about modern developments with MCP and OpenID Connect and OAuth and so on. If you have urgent questions about authentication and MCP, come to me in the break, okay? Good. Do you want to see code? Let's take a look at code, okay? Yeah, question, please, go on.
Copilot in Visual Studio talks with GitHub because it searches repository. Is that also already one of those right-side data sources, or is it meant to be, it can create the repository in GitHub, that's the MCP connection? Which one of those two is it both? That you say, okay, so that Copilot can create the GitHub repository is the kind of stuff you mean here, or
yes.
is it searching in GitHub already? Is it both? Is it one of those?
If you take a look here, then you will see that I have already installed GitHub here. That's a ready-made MCP server. By the way, you can find many public MCP servers through the GitHub MCP registry. It's under github.com/MCP. Here it is. So you can take a look at that. There are tens of thousands of MCP servers out in the internet, but please be very, 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 very careful when using MCP servers with your precious code and precious data. So only take trustworthy MCP servers, and this is quite a good source for MCP servers. So what you see here, to your question, if I scroll down, you will see the GitHub MCP server listed here. So what you can do is you can take the GitHub MCP server, install it in Visual Studio Code, and then give the tools that the GitHub MCP server provides via Visual Studio Code to the large language model. And suddenly, the large language model becomes capable of reading issues, creating pull requests, branches, repositories, list repositories, whatever tools the GitHub MCP server provides. So take a look. If I go here and take a look at the GitHub MCP server, here it is. Here we are. And then you see these capabilities. They're all GitHub MCP server provided capabilities. I will not focus so much on using existing existing MCP servers because the talk was deep dive into the protocol. But there are many of these, and I hope that answers your question. Only by installing this MCP server, the large language model becomes capable of interacting with GitHub. Otherwise, it can't. Make sense?
Sure.
Okay. Any further questions before we take a look at code? I will not write code today. I will just show you code, but we'll do a code walkthrough. We can debug it. We can change it on the fly, whatever. Okay. The first example that I built for today is this one. Let me zoom in. It's called MCP server no SDK. Never do that in real life. That's just an experiment. Just to show you, we don't need any SDK. All we need is the capability to do a console read line and a console write line. With these two commands, you can build your own MCP server. And this is what we are going to do. And in the process, we are going to take a look at the protocol. Let's take a look at our program here. The first thing that we see here is a loop. This loop essentially waits and listens on standard in. Whenever we receive something on standard in, we know that's an MCP command. Now the question is, how are these commands structured? And the answer is JSON RPC. I don't know if you are familiar with JSON RPC. If not, please take a look after the talk. JSON RPC is a really simple protocol. Essentially, it's a JSON where you have a little bit of a header, a method name, and arguments. That's it. It's really a very trivial RPC mechanism. JSON RPC does not state that this must be transferred via HTTP or anything else. It doesn't matter. It's just a remote procedure call encoded in JSON, and you have to respond with the results in JSON. That's it. And this is what MCP is all about. It's just a bunch of standardized JSON RPC calls. So what I do here in this line here is I'm deserializing this JSON RPC call. Want to see a JSON RPC? I will show you. So just that everybody has seen JSON RPC before. I'm looking for a quick example. I'm pretty sure, yeah. I mean, do I have to tell you anything more? That's JSON RPC. It's as trivial as that. Yeah, small header, method name, parameters, resulted JSON. That's it. It's so simple, sometimes it's strange that these things have names. Now, for the MCP protocol, there are three, at least for now, three important JSON RPC calls. The first method is called initialize. It's essentially a handshake between the client and the server where both agree to talk JSON RPC and to talk based on a certain protocol. Essentially, the client goes to the MCP server and says, who are you? What is your version? What version of MCP do you speak? And give me a description of yourself. Okay, that's the initialize stuff. Then the next call is a tools list. The MCP client goes to the MCP server and says, what are your capabilities? What can you do? What functions are built into your application? Okay, that's the tools/list method. And finally, the thing can call a tool, tool/call. That's it. There are more things related to MCP, and I will show you that in a second. So let's take a look at handle tool calls to see that very simple. What I essentially do here, I am validating that in this case, the name is winter password because we built a password generator. Just to give you an idea, I have built a number of winter-related words. Sorry, they are in German. And we are generating super strong passwords by concatenating these words. Okay, that's the business logic here. Business logic. So we are just checking. Currently, we only support a single JSON RPC tool, a single MCP tool. If it's correct, I get out, as you can see here, with typical JSON stuff, the minimum length of the password and whether we should encode special characters like turning O into 0 and E into a euro sign. I think you get the idea. And then we build the password and we return, as you can see here, a JSON with one property here, which is called content, and then here an array where we put in a text result, or we could also generate images and return an image result, for instance. That's also fine. Okay? And that's it. That's all there is to say. Let me show you that this in fact works. So what I did here is I configured these MCP servers, and what I can now do is I can start this MCP server. This is exactly the MCP server here. And as you can see in Visual Studio Code or in any other AI tool, they all work the same. This is a standardized format. You simply say, I have stdio, run.net, run project MCP server no SDK. It's this one. It's now running, and as you can see, it has one tool. See? And now we can try it. So what we do here is we start a new thingy here. We take everything away except built-in and no SDK. See? I'm giving this tool to the LLM. I'm using Sonnet here, so please generate a winter password with min length 35 chars and special char replacing. If I run this, the system will hopefully detect that we have an MCP server going on. And you see, I get asked whether I want to call this MCP server. So this is now sending a JSON RPC via standard in to MCP. I can allow this thing. It's calling, and this is the strong password. Okay? Fair? This was the point that I wanted to make. So remember, MCP is JSON RPC first. Remember stdio. And remember that we do not need a library for that. We can build it with anything that talks standard in and standard out. Fair? Good. Next step. Of course, it is much easier if we have something like this. Oops, sorry, that was the wrong one. This one. Please note that this is preview. It's not final. So we have an SDK for C# that makes it much easier to do essentially the same. And for those of you who have never built an MCP server, I have good news for you. It's really trivial. Take a look at this thing of beauty here. Particularly here, small little attribute on top of a class. Here, small little attribute on top of a static method. Here, a little bit of metadata, as you can see here, and that's it. That's it. Nothing more. You can take an arbitrary C# logic, wrap it in a static class, put a bunch of attributes on it, and you're done. Your MCP server is up and running. And the good thing is, if you build something like this, it is completely independent of whether you use stdio or streamable. The code is exactly the same. It doesn't matter if you run it through standard in and standard out, or if you run it through streamable. Code is exactly the same. Here, you can do whatever you want. Of course, you need a little bit of code to set everything up. And for stdio, that's really, really trivial. You create a host with the typical application builder, and you add the MCP server. You add the stdio server transport. Please ignore this for now and this for now. We'll talk about that in 30 seconds or so. Then you call build and run async, and that's it. That's all you need. It will look up all the static classes, run the tools, and you're good. You can immediately use this thing. It works in Claude, it works in Cursor, it works in Visual Studio Code, it works in a custom client. Yeah, absolutely no problem. Question?
Is it using source code generators or reflection or?
Reflection.
Reflection.
Yeah, it's fully based on reflection. Yep, yep. To be honest, it really doesn't matter because LLMs are so horribly slow that any performance optimization that you invest doesn't make any sense because you have to wait for seconds, if not minutes or hours for a response, literally minutes, so it really doesn't matter. At least for now. If LLMs become super, super fast, maybe it will be a thing, but currently it absolutely doesn't matter. Okay, so this is this one. Do I have to run it? I don't think so. You trust me, right? You have seen the tool. Now let's go one step further because I told you that this thing knows more. So here you see a bunch of tools. This is one tool, and there is another tool, but this thing can do more. As you know, sometimes it's really boring to always have to type in here. It's really boring to always have to type in the prompts, right? It would be super, super useful if we could embed our prompts in some kind of library which we could hand out to all our users so they don't have to type in so much. And guess what? MCP supports that. So what you can do with MCP, you can not just add tools, but you can also add prompts. A prompt is nothing else than a string. You can still ask for input parameters, and you can add arbitrary C# logic to build the string. Okay? So imagine that you have reoccurring use cases where you build complex prompts. You can put them into an MCP server, give it out to your users, and suddenly all these users can easily reference the prompt, right? Now I could show you that in Visual Studio Code, but I would like to introduce you to another tool which is super, super useful. Let me show you what I mean. In my small little demo here, yes, it is a .NET project which has a Node modules folder. Oh my God, don't throw me out of the window. The reason why I have a Node modules folder here is there is a tool which we really, really want to use, and that is the inspector. The inspector, I can't help, I'm old enough, I always hear inspector gadget in my mind when I hear that. But it's an inspector. And this inspector, like a doctor, you can use it instead of an AI tool to test your MCP service. Let me show you what this means. Let's go into the MCP server SDK, I think it was called, right? Exactly. Oh, sorry. npm run inspector SDK. That's it. Yep. May I introduce you to the inspector? This is the inspector. What we do is we switch to stdio, and as you can see here, it's again .NET Run MCP Server SDK. I can click on Connect, and this button here, Connect, will run the command line in the background. So the inspector consists of a server part, which essentially is a web server with an API, and the client part, which is just a JavaScript-based single-page app. So these talk to each other, and the .NET Run statement is executed by the server, not by, obviously, I mean, of course. And here, we can now do these things. See, tools, list tools, winter password, generated, and here you have the password. And here I can now show you the prompts, list the prompts. This is the prompt that you just saw. I would like to enter a minimum length of 20, and I would like to say, yes, please, true. Please do special replacement. And if I click on it, see here, I get the build prompt here. See? So the MCP inspector is a really, really nice tool to debug your MCP servers. You don't need to try that in Visual Studio Code because that is much harder to debug. Got it? Make sense? If it works with the MCP inspector, you have, no, other way around. If it doesn't work with the MCP inspector, you don't even have to try it with Visual Studio Code. If it works with MCP inspectors, you might have a chance that it runs in Visual Studio Code. Because as with all standards, there is the standard and then you have the implementations. And unfortunately, the implementations are not perfect. Visual Studio Code, in fact, is, in my experience, the tool that implements the MCP protocol for the completest way. Cursor is much worse. Google Anti-Gravity doesn't implement MCP currently, I think, at all. I'm not sure, but it's really not good. Claude Desktop is a decent implementation, but it supports lots of standard parts. It doesn't support these. And ChatGPT is the worst. ChatGPT is horrible when it comes to MCP servers, unfortunately. Yeah? So you have to test your MCP servers with the inspector. If it runs with the inspector, you have to read the documentation of each tool. It reminds me of my early browser development tools when you had huge discrepancies between, I don't know, Firefox and Internet Explorer or something like this. Nowadays, it's still there, but it's much less, the differences between the browsers. And currently here we are in the Wild West zone. So yeah, a lot of white hairs come from this stuff. Okay, so you now saw the inspector and you saw prompts, but we can do more. Yes, REST is back. Only no, not the state transfer, just the get part of REST. What you can do is you can provide resources, which are essentially static data whatever that can be returned to the user. For instance, you could model file system read access through resources, but you could also model them through tools. It depends on what you want. Okay, it's very similar to a web API where you can use something like gRPC, or you can do something like REST. And the same is true here. So resources give you a possibility to model the read access to certain resources like files or database records in a more natural way. But for now, this really is not important for everyday work because only a few tools out there support resources. So mainly, this is not used, and you simply write tools because tools are widely supported, resources not. But it's still there. So if I go up here, I can go to, see, resources. I can list the resources, and in this small sample, I can, for instance, ask the MCP server for all the different names which are used to build the passwords. A hacker's dream, right? I think you got the idea. Okay, good, nice. Any questions regarding the MCP server SDK? It's in preview, yeah, but it's okay. C# is well supported. Python and TypeScript are a little bit in front, but it's okay. No complaints here. Next thing, let's take a look at this one. This is this is a little bit more complicated. I hope it's okay if I use MTech again as an example. Imagine that a software provider like MTech wants to offer an MCP server, and one part of the MCP server is to do a summary of the health situation of the customer. Security nightmare, but bear with me. Just as a thought experiment. In a perfect world where everything is safe in the cloud, let's say we do something like this. The problem is, if MTech offers this MCP server, then a user comes to it and says, please summarize this data. But MTech really does not want to pay for the large language model for summarization. Get the idea? If they would do that, they would have to charge the customer for something, but the customer already pays, for instance, for GitHub Copilot, or for Claude, or for ChatGPT. Why can't the MCP server go back to the large language model that the user already has licensed and ask it for participation in solving the task? It's a kind of back channel. So the large language model comes and says, please summarize. And then the MCP server says, okay, I can summarize. So back to the LLM, please summarize. Then the LLM will do its task, send back the response, and then the response will go back to the LLM. Get what I mean? And this is what we call sampling. See? This is an interesting winter password sampled. This is a variant of my example where I don't have a static list of words for passwords. Instead, what I do is I ask the sampling chat client. I go back to the LLM and say, nice LLM that you want to have a password, but first I need 30 distinct winter-related words in German from you, because that is the basis for my work. Get it? And the point is that we use the license of the end user that he already has. Okay, and we can simply do that, very, very simple, and then use it. Let me show you how this looks like. Then it will be pretty obvious and clear. So here is the sampling one. Let's start this one. We have one tool, as you can see here. Now let's go here. This one. Remove the no SDK and add the sampling here. Now please recognize or note this cogwheel here. Let's click on it. If I click on this one, I can go to more, and here you see configure modal access, set the modals that server can use via MCP sampling, you see? So I can click on that, and I can say here, yes, the MCP server is allowed to use the Claude Sonnet 4.5 modal if he needs it. So the MCP server gets my permission that it can go back to the LLM and ask the LLM to do certain tasks. And this goes through as the end user, through my subscription of GitHub Copilot. I'm paying it with a premium request of GitHub Copilot, not the provider of the MCP server. I, as the end user, am paying for this request. So let me show you how this looks like. Please generate a winter password with min 35 chars. I hope it will work. Winter password, no, this is no SDK. Why no SDK? No, this is not what I wanted. I'm sorry, I have to go back. Probably, yeah, I didn't change that one. I'm sorry, I didn't press the OK button. So let's try it again. That was my mistake. Much better. Here, see, sampled. Good. So now I can say allow. Now something interesting happens. The MCP server sampling has issued a request to make a language model call. Do you want to allow it to make requests during that call? And in this case, we say, of course, go for it. What could possibly go wrong? And as you can see, we have an input, and hopefully we get a password. Oh, an internal server error has occurred. I love that. Let's try it again. Okay, no problem. What we can do is we can take a look here with the sampling MCP server. Where is the sampling MCP server? Here it is. I can take a look at the last sampling requests. See here, that is 1812. I think that should be okay because we have 1 hour. And what did it do? It looks pretty okay, the response. I don't know why I have a mistake. Okay, doesn't matter. I will not look for the problem here, but simply trust me. It looks pretty okay. So yeah, it does the request. I don't know what the problem is. I've screwed up, sorry. But you trust me that it should work. I will take a look at it. Got the idea about sampling? Okay. Let's spend the last 5 minutes or so switching from stdio to streamable. I will finish at approximately 7:20. I hope that's okay. That's 5 minutes more. Yes, question, please.
If you use the back channel, is
Uh-huh.
the LLM also allowed to use other MCP servers?
No,
No, okay.
no. It's just directly talking to the LM. No MCP servers there. Now, what is the difference if you want to run this in HTTP? It's really not a lot. All you need to change is one line. This one. Can you remember what we had before? With stdio transport. That is what we had. Now, we have with HTTP transport. The second thing that you have to change is the host. Previously, we had a console app. Now, we have an ASP.NET Core Minimal API app. So what we have, if you take a look, is we have now a web application create builder. We have some course policies. Course, the greatest invention in web development ever. I never had problems with course in the past, never. Then you just add this one. Everything is pretty normal. You can combine regular HTTP handlers with MCP, absolutely no problem. The only thing that is important is this one, add MCP, map MCP, that's one. And then you have exactly the same tools. That's the point. You can write your tools and they are completely independent of the transport, and then you plug it either in a console app with stdio or an ASP.NET Core app with a streamable protocol, and that's it. And it works. So what I did in order to demonstrate that is I set up essentially exactly the same application with the winter password with a few more twists that we will spend the last 5 minutes on. First, let's run this guy. Now it's no longer a console app. We have to run an HTTP server. And of course, in .NET, what do we do if we run MCP servers or web applications in general? We use Aspire. Obviously, if you haven't taken a look at Aspire, please do so. It's one of the greatest additions that Microsoft recently did to .NET. It's now no longer called .NET Aspire, by the way. It's called only Aspire. So it is no longer a .NET project. Yeah, it's still driven by .NET, but it works flawlessly. No, not flawlessly. It works quite good with JavaScript, with Vite, with React, with Python, with mixed applications. I really like Aspire. I really, really like Aspire. And what I did is I set up an Aspire host. This is not an Aspire talk, but you can see that because here you have the app host and the service defaults. So what I need to run here, .NET run project app host. I run the Aspire host, and the Aspire app host simply references my MCP service. So you can build an MCP server that has a huge distributed backend in the back. So you can, with Aspire, spin up your databases, your, I don't know, OLAMA models, your message brokers, your backend microservices, whatever you spin up. And at the very top, you have your MCP service. And they all work together in a very, very nice way. So Aspire is a great way of developing MCP servers with the streamable protocol. As you can see here, we have our demo server, and we have the MCP streamable server. And if we take a look, the MCP streamable server listens on port 5186. If you don't know it, Aspire puts a load balancer in front of the web applications that run on your computer. So you can even run multiple instances of this thing and support and simulate multi-instance fail-safe deployment in a cloud, for instance, very easily with Aspire. So this is the address of the load balancer, 5186. So if you take a look, what I did is I took exactly that one, and as you can see, if I start this thing, it immediately goes to running, and now we no longer have .NET Run, but we have a URL. And that is what we can do. We can take an MCP server, put it in the cloud, add a little bit of authentication on top of it, and all our customers suddenly have access to their software as a service application through ChatGPT, through Claude, through Visual Studio Code, whatever you want. Really, really nice. Okay, so this thing now runs. Let's take a look how it looks like, and I will demonstrate that first in the inspector. Let's see if I have it here in my recently used list. This one? No. Okay. I shouldn't have closed my window from before because I don't know the entire line by heart. So now I have it. So run the inspector, and now I switch to streamable HTTP. And this is exactly the port that you just saw here, 5168, 5168. I can connect to this thing, and please recognize that here you see direct. See that one? You can choose between via proxy or direct. If you have an HTTP-based web server and you use direct, then the web browser is directly accessing your MCP server, and therefore you use CORS. If you say through a proxy, then your inspector goes to its own backend, and the backend does the HTTP request to the MCP server. Okay? So for debugging purposes, it's really nice to have the possibility to go directly through the browser, because with that, I can open up my network tab and show you what's going on the network. I'm super sorry. I have to make it a little bit smaller. I will zoom in as soon as it gets interesting. So let me show you that. Let's go to Tools and say List Tools. And what you see here we are, is an HTTP post. The payload, can you remember? JSON RPC. Tools list, can you remember? We had that at the very beginning of my talk. And here we can take a look at the response. Ooh, the response is empty. That's a problem, right? No, it's not a problem because everything runs through SSE, server sent events. Here you would see the server sent events. I was a little bit too slow, but you will see them in a second, okay? So everything goes through server sent events here. Good, let's take this password here and take this one and run the tool. And here, as you can see, we really have the response through SSE. And if we take a look at the payload, this is exactly the JSON RPC call going through HTTP and the streamable protocol. If we would have authentication required, we would also get an access token so that we know the identity of the user. Got it? Make sense? And this is exactly what we want. Now I told you that this thing is pretty amazing because, and that's the last thing, I'm going to take until 25, I'm super sorry. But I think this is really interesting. Take a look at this one, that's the last one. Elicitation. The MCP server can ask the AI tool to ask the user for additional input. That is a very, very powerful tool. Let me show you how this looks like. I will show you that here, and trust me, it works equally well in Visual Studio Code. So what we are going to do is we are going to use this version of the implementation with custom words. You see that one? So let's run the tool, run. And the first thing that you see here, use custom words. So in this case, the scenario is I don't want to use the provided words by the application. I want to provide my own list of words which are concatenated to a password. So I say, yes, please do so. Then I get asked for input. You see elicitation? And now I can provide my list of words. And please take a look at the event stream here. The SSE asked me, do you want to use custom winter words? Enter your custom winter words. So you see the whole communication between client and server works through a single SSE connection. So let's provide the custom words. ICE, Snow Christmas. Submit. And you see, this goes through, and now I get the password. So elicitation really works nice, and this works equally well in Visual Studio Code. Last demo, here you see MCP streamable server. I will try my very best to not screw up. Here, make sure everything is turned off instead of MCP streamable server. And from MCP streamable server, I will only allow the one with the elicitation because everything else is plain vanilla. Please generate winter password with 35 chars. And take a look what's now going to happen. Yep, allow. See, this is elicitation. Do you want to use custom winter words? Yes, I would like to respond. And the answer is true. The MCP server wants to ask you for a list of custom winter words. Do you want to respond? Yes, I want. Give me a list of words. Ice, snow, Christmas. Okay, that's it. And now I hopefully get a password. And here it is. See? So elicitation is really a very, very powerful tool. And because you have that in Aspire, you get all the nice things, like, for instance, tracing. Isn't that amazing? We can dive into the details. We see all these events going on. That's open telemetry. So we have open telemetry with Aspire, with MCP server, all nicely to debug, running on a web server, locally or in the cloud. You can put it in a Docker container. I think this pair, Aspire with MCP, and ASP.NET Core Web Minimal API is really a match made in heaven. You can find a lot of arguments against MCP. MCP has its flaws, no question about it, but at least we have a standard. I'm grateful for having this standard because we can do amazing things. And Stropek is already working on the next version, next iteration of MCP that will hopefully remove a lot of the downfalls that MCP currently has. My talk today was about a technical deep dive in MCP, and I hope you could take away something from this talk. Maybe a detail about the protocol, maybe some aspect of MCP that you weren't aware of, maybe even some foundational knowledge about function calling, tool calling, and so on. And with that, I want to say sorry for overshooting by 10 minutes. I hope it's okay. Thank you very much for listening. I will stay here for a little bit more, and we can easily have a chat out there with food and drinks. So thank you for having me, and yeah, looking forward to the discussion on the hallway. Thank you.
Do we have any questions? Final chance. Not yes, final.
Please. So, thanks for the first of all, it was really interesting.
Thank you.
The thing that I'm wondering is, like, how can you reliably use a function from an MCP server? Because in our case, it was very obvious that we wanted a password from your function.
Yes.
But what if, let's say, I go to GitHub and install some custom MCP server for React? And I implement a function that explains the new React 19 features. And then I ask, maybe not directly for React 19 features, but how does the React compiler work? And how can I make sure that the function is called from the MCP server and not some random information from the internet?
You can't. It's as simple as that. You simply can't. If you want the large language model to use your MCP server and it's not obvious from the use case, you have to be explicit. That's it. Practice prompting and try to be as explicit as possible. So for instance, there is a Learn Microsoft MCP server. An MCP server which essentially makes this input field, this one, available through an MCP server. If you, for instance, want to generate C# code and you provide this MCP server for Microsoft Learn, the LLM will not because of whatever, ask for, tell me about the latest C# features of C# version whatever's actual, it will not do that. If you want the LLM to, for instance, use the new C# 14 whatever extension block feature, then you have to tell it. You have to say, use the MCP server, learn Microsoft to research about C# extension blocks and use this feature when you generate code. Then it is very likely that the LLM will do so, at least the modern ones.
And is there any way to explore the API of a specific MCP server?
You mean that you have, let's say, a repository out there with thousands of MCP servers, and the LLM is not depending on you setting these checks, but autonomously going through these registries, finding for maybe a possible MCP server, something like this?
Actually, within one MCP server, if I don't know the function names and I want to
Yeah, absolutely.
MCP clients to
Absolutely, absolutely. If you click here, for instance, Microsoft Learn, here, see, you'd see it directly here. You can read on it, and you can also take a look at the GitHub repositories of these MCP servers, and they have all the names documented. And by the way, that's the huge disadvantage of MCP. You, as the user, have to choose the correct tools. It would be much better if the large language model would have a capability, something like the LLM gets some kind of Google for MCP servers, and it autonomously finds the MCP servers that might be useful. That is the next iteration of MCP, but we don't have that yet. That is the thing that everybody is talking about now for the next big thing in 2026. Good? Did that answer your question?
Yep.
Good. I think we had here one question.
To piggyback on this question here, so technically, at the start of the talk, you were talking about the personas.
Yep.
So you can theoretically add to the persona that it should use these and these functions in these and these,
Yeah.
these cases.
What I often do is, if I have a project like that, is I'm using the agents.md file. And in the agents.md file, if you don't know what agents.md is, take a note and take a look. You can write some coding guidelines. And you can, for instance, say, if you generate Angular code, research the context 7. If you don't know what context 7 is, take a look, take a mental note. You have to research that. Research the context 7 MCP server for latest developments in the Angular framework regarding signals, for instance. You can do something in agents.md, and that agents.md will automatically be copied into each interaction that you have with the LLM, and therefore the LLM will always be told to go to context 7 and research for API changes in Angular. So it's only a shortcut so that you don't have to type so much, but it's a useful shortcut. Okay, does that also answer your question? Yep, great. I think we had one at, yep, please.
When the MCP server requests that it can use the model itself on behalf
Yeah.
of the user,
Mm-hmm.
does the UI, also the front end, share the credentials with the MCP server, or is the MCP server using the front end as a proxy, so to speak?
It uses the front end as a proxy. It does never access the LLM directly. It goes to Visual Studio Code, and then Visual Studio Code goes to the LLM. Mm-hmm. One final question, if we have one. Otherwise, I think we can close it and walk over to soft drinks, beer.
Yeah, we're gonna wrap it up for now. Thank you very much, Rainer, for coming again, for offering us the opportunity here in the room. As usual, we got a small little speaker present.
I love Linzer Torte. Thank you very much.
Thank you very much. And again, big round of applause to our speaker from tonight.
Thank you.
Good.